Welcome back to Ukulima Mazao Bora, and today we go back to ADC Genetics Center, where cutting-edge technology and meticulous expertise converge to unlock the potential of livestock genetics. In this segment, we delve into the fascinating laboratory process that transforms collected semen into a powerful tool for livestock breeders, as well as the state-of-the-art storage facilities that ensures its longevity. The laboratory at ADC Genetics Center is a hub of scientific excellence. Here, high-skilled technicians employ precise techniques to analyze and process the collected semen samples. Under the careful guidance of genetics and veterinary professionals, every sample undergoes a rigorous evaluation to assess its quality, concentration, and motility.
Welcome to the lab section. My name is Dr. Muse. I work here in the lab. So after we have received the sample that has been collected from the bulls. We first of all start by preparing these machines so that they can be at a certain temperature, in this case 37 degrees, because semen is sensitive to rapid temperature variations. So we want it to be as near the body temperature of the bull as possible. So we set the machines. This is called a water bath. It has water in it. So we make sure that the water is at 37 degrees. So when the sample comes in, it finds the machines ready. So we get the sample from the bulls, and then we immediately put it in the water bath, and then we go ahead and examine it by taking a sample. With this pipette, just a small sample.
Using advanced microscopic analysis, they examine the semen for any abnormalities, ensuring that only the highest quality samples progress to the next stage.
Put 2 drops, and then we put a cover slip on one of the drops, the smaller drop. We want it to be as small as possible so that when you put the cover slip, the semen can spread as much as possible, if possible to just one layer. And then I'll examine it under the microscope and see whether it's there's a nice wave, whether there's what we call the mass motility. And then when I see it has a nice wave, I know that most of them are alive. So I go ahead and examining them a bit closer so that I can see the individual motility. The individual motility, now you can see it from the screen. This screen is just connected to my microscope, so you can be able to see the individual motility. As you can see, most of them are motile. So this is a good sample. It can go ahead for processing because most of them are motile. I think it's just 1 or 2 which is normal. For any sample, you can find 1 or 2 that are dead, which is normal. But if it's anything beyond 80%, then that is good enough for processing. And as you can see, most of them, this is way above 80%. So you check whether there's what we call the progressive motility, whether they are motile progressively. So after that, you check the live dead ratio. Like I said, the more, if 80% are alive, then that's a good sample. And then you also go ahead and examine the sample for color. The normal color should be cream in color. You examine for, if you see maybe it has some pus or it has some blood, then that's a bad sample. You don't go ahead with processing it. If you see it has too much hair or too much dirt, you don't go ahead and process. You just leave it at that stage. You just discard it. But if it's okay, you go ahead and you know, it can now go to the next step. The next step will be to put a sample of that semen into this machine. It's called a photometer machine. The photometer compares the concentration, it gives you the concentration of the spermatozoa. Once you get the concentration of the spermatozoa, this machine will also tell you the amount of deodorant that you can add in that particular sample, because you want one straw to have at least 20 million spermatozoa in progressive forward motility. So this machine will tell you the amount of diluent that you need to add, because semen comes in when it's way too concentrated. For example, the sample that you've just collected, it was 6 ml and it had a concentration of 2.9 billion spermatozoa per ml. So it was quite concentrated. So we need to dilute that so that one straw can have at least 20 million live spermatozoa. So this machine will tell you the amount of diluent to add. In this case, we need to add 183 milliliters, and therefore the total dose, if we add that, because one dose is 0.25 ml, then it means the total doses that we are going to have is 820 doses from that one ejaculate alone. Yeah.
And this diluent?
Yeah, diluent. Yeah, diluent.
But it's the chemical, what is it?
So this is what we call the diluent. It's already prepared. We import this from France, from a company called IMV in France. So it comes already prepared. So it's a concentrated solution. It has the right amount of antibiotics to prevent the semen from being attacked by bacteria. It has the right amount of antifungals to prevent any fungal infection. It also has some nutrients, in this case a sugar called fructose. It also has what we call a cryoprotectant. A cryoprotectant is something, after this you are going to freeze the semen, so in order to help the cell not to burst, it needs a cryoprotectant to coat it such that it won't burst. As you know, semen contains water, and what happens when you put water in the deep freezer? The water bottle expands and it can even explode, right? So it's the same thing that will happen to the cell. Once it has been frozen, it will expand, because water undergoes what we call anonymous expansion of water. So at a certain temperature, it starts expanding instead of contracting. So it will the cell will burst when you put it in a cold environment. So we need to get the water out and put something that will not undergo that expansion. In this case, it's called glycerol. Glycerol will not undergo that. So the water will come out and the glycerol will come in. And therefore you can be able to freeze that semen comfortably, because now it's protected. That's what we call a cryoprotectant. It's still contained in this medium. Yeah. So what we do, we take this medium and mix it at a ratio of 2 to 1. One of the diluent and 2 of sterile water. This water has already been sterilized. We have some sterilization machines here, so it's already sterile water. So you mix them in a ratio of 2 to 1 to give you the final buffer. So that is what we use to dilute the semen. It's called a semen extender. Yes. So after that, you mix the sample that you had collected with the extender, and this is the end product.
Now, through precise measurements and controlled conditions, the semen is prepared for optimal storage and future usage while maintaining its genetic integrity.
This one now has been mixed and labeled. We had collected from a bull called Super, and we have added 183 ml. So this one, after that, you put it in this water bath. This water bath is just water that is at 37 degrees. Yeah. So after this, you now let them cool slowly from the 37 degrees to the room temperature, which is about 22 or so degrees. So we just leave it on the bench for them to cool, for it to cool together slowly. Because if you just let it stay on the bench, you are just dropping it from the 37 to room temperature immediately, and that will cause a lot of stress in the spermatozoa, and most of them might die. So you let them, you put it in the water bath so that they can cool slowly. After you have extended it like that, you can, it's always safe to take another, to take a sample of the same to see whether the concentration has has dropped, or whether maybe the diluent could have been having some problems, because all these things are very sensitive. Everything is very temperature specific, so it's always good to take another sample just to check whether the spermatozoa have been affected so far before you take them for cooling. So you just take a small drop and examine. You put a cover slip again, and then you examine under the microscope. So you can see the spermatozoa have not, they are now dilute, they are a bit dispersed, and they are very active, they are motile, because now they have gotten the sugars and things like that. Only the dead one or two which were dead, which is normal, are not moving, but the others are quite good. So this one is a very good sample for processing. Yes. So from there, now we take our sample and put, like I said, everything here is completely temperature sensitive. Even these beakers that we are using, we have to make sure that they are 37 degrees. So this is an oven that we put everything that we are using, or everything including these pipettes that I'm using to pick the sample. As you can see, it's at 97. Even this stage of the microscope is also at 37. It's controlled by this gadget here, so it's at 37. So everything is temperature controlled, so we need all the equipments that we are using to be at that temperature. So we put them here, and then we set it to be at 37, and therefore we are comfortable that everything that we are using will be at that particular temperature. Yes. If you pick maybe from this desktop here, this one is it was at room temperature, so at around 22 degrees, and then if you introduce semen in it, that rapid temperature drop will kill most of the spermatozoa, so it needs to be cooled down a bit slowly. So that's why everything has to be set at 37 degrees. Yeah. So and then if we are in doubt, we can use this machine. Is called a CASA machine, computer assisted semen analyzer. At the moment it needs to be serviced. There are some parts here which needs to be serviced, so it's not possible for me to demonstrate, but if you're in doubt what you are seeing in the microscope, you can take a sample and put it in this computer. It's a computerized semen analyzer. If you look on this side, it actually has a microscope of its own. So it's a microscope connected to a computer, which will analyze everything in much more details. It will give you the live dead ratio, the ones with the deformed heads, the spermatozoa with the coiled tails and all that. So it gives bigger details. But that we use this one when we're in doubt. Okay. Yeah. So this is, and then after that it has its own system. It will generate a report like this one. Yes, it will tell you the total, the ones which are motile, the ones which are moving slowly. So you have a complete picture. So we usually use this machine when maybe a client has some dispute, or when you want to generate a good report so that we can maybe export the semen or take it to sensitive clients and things like that, and also routinely every now and then, just to make sure that whatever you are distributing out there is a good quality. So usually this is the kind of report it generates. The motility, morphology, it will tell you whether it has bent tails, whether it has coiled tails, whether it has what we call the cytoplasmic droplets, the proximal and the distal cytoplasmic droplets and all that. And then you know, it gives a complete, well-detailed report like that one. So all these others, we use them in the processing. This is our weighing scale. This is our weighing scale for measuring different reagents, the volumes and the weights of different reagents.
Okay.
Yeah, it's quite sensitive. It can give you up to the thousandth a measure of something that you want.
Okay.
Yeah. So, and this is the rest is just an accessory printer. We are going to see that. So after we have collected our sample, we'll take it to, we'll put it in this fridge. We'll set this fridge at 4 degrees, and then we now put our sample there together with the water bath, so that they can cool slowly from the 37 degrees to 4 degrees for a period of about 4 to 6 hours.
Okay.
Yes. So if we did this collection in the morning, we let it stand there up to around, if we did it up to around 10 in the morning, we let it cool at up to around 2-3 thereabout.
Okay.
Yeah. So alternatively, instead of switching on this machine and letting it run, we can put the samples in this machine. It's called the cooling chamber. Yeah, we can come and just leave the samples here for it to cool slowly from that temperature up to 4 degrees. It's usually set to operate at around 4 degrees. You can see the temperature here is around 5.4, but it's because I've just opened it. Normally it will be at 4 degrees. So after that, it has its own light. Yeah. So everything here is now at 4 degrees. This collection we had collected it in the morning, so it's now at 4 degrees. Yes. So after that, after everything has been set, we are going to fill the the semen sample into straws. So here now we will now be operating at 4 degrees. So everything now has moved from the 37 now to 4 degrees. So everything is at 4 degrees, including the straws that we are filling in. We had left them here, and this chamber we have already said is at 4 degrees. All these racks that we are using, wherever you are, everything that we are using to arrange, the needles that we are going to use for filling, everything is at 4 degrees. Okay? Yes. We cannot go higher. We cannot go, so if you have come down to 4 degrees, you cannot increase the temperature again. That one will subject the spermatozoa to death. It's going to shock it. So we will be operating at 4 degrees. So this is a machine. It's called the MX4 machine. It can be able to fill the spermatozoa. It can be able to seal the straw, and it can be able to print. It has its own computer, but the printer has got an accessory computer here. So this is the printer this is where the mixing of the ink will occur, and then now this computer here is going to control the printer. This part is what I'm calling the printer. This part is the printer now. Yes. So the straw will be picked. The straw will be picked and placed, 4 of them at a go. As you can see, we have 4 needles. So 4 of them will be placed here, and then these 2 portions here will come together and lock the straws. and then after that we use negative air, to suck the semen into the straw. So the semen will be sucked from this end by a negative vacuum. We use partial vacuum. We create a partial vacuum that will pull the semen from this point here and fill it into the straw. For example, the semen we collected, we will pick it and then we'll swirl it a bit and then pour it in this portion here. And then after that, sorry, this place is a bit full. Then after that, we are going to lock the place, and then we'll start the machine. We'll start the machine. So just observe how the machine is going to behave. Then I'll explain.
Okay.
Sorry. You can use this one to send the information, the internal computer or the external computer. We are using the external computer. Just observe how it's. So the semen is being filled here. These needles are coming together and then sucking, the semen from this end. So it comes in there, and then when it reaches here, this place is heated. So it seals it. It seals it. So it has already been filled here. So it seals here. The straw itself comes. The straw itself comes like this. So it has two ends. One end is open, as you can see, and the other end has got some cotton sealed.
Yeah.
So this cotton sealed end, this cotton sealed end is the one that is on this side. So these needles will come in here, and then these ones will suck, because of the negative pressure, it will suck in the semen from this portion here. And then once this straw is filled, this end will now be heated, pressed and heated, so it is going to seal up. Okay. Once it is seals up, it now falls here. Now we'll release some ink on it, and then it will print the information that is on that computer. And then the straws will come to this end, and they have already been filled. You can see they are filled. You can see if you look here, you can see it has been filled, and then it has been sealed. You see, it has been filled, and our printer, we had not set up the printer, but the printer will print all the information that was there like this. Yes.
So this is the template?
Yes. It labels the name of the bull. In this case, you are filling this bull called Super. It will label Super, it will label a station, and it will label the date of the collection and filling. Yes. So after this machine is fast, it does 4 straws per second. That's quite fast. So after the straws have been filled, we are going to we are trying them in this rack. We set a rack like this way. Yeah, and then we put the screws on this rack. You don't get them out because we need them to be where hot. Yeah, in the cooling chamber. So we arrange them like that. In this rack. So all the taste collection will be arranged in this rack. Like that. So we'll arrange all these racks. We usually do a collection of about 5,000 straws. One rack can hold 175 straws. Yes. So after we have filled all the racks, we are going to pick them like this, and then transfer them to this filling container, like that. So this filling container, freezing container, sorry. The freezing container, freezing, is controlled by this computer. Yes, so this computer is the one that is going to charge with some liquid nitrogen periodically through this place here. To pull it now, systematically pull it from the 4 degrees that you are operating it to negative 145 degrees for a period of 15 minutes. Yeah, so this is where the liquid nitrogen will be coming from. It will be controlled by this computer. It will be increasing the liquid nitrogen slowly, therefore bringing the temperature down from 4 degrees to negative 145 degrees. So this is the curve that would be observed. You are starting at 4 degrees, come down slowly, then after that, it rapidly until it reaches negative 145 degrees. Yes. So after that, well, all this time, of course, the chamber will be closed.
Yeah.
Yes. This time the chamber will be closed. After that,
Now, let's explore the vital aspects of semen storage.
okay, after now the 15 minutes, everything will be frozen. We'll just pick all the semen. Now, then drop it in this chamber here that has got liquid nitrogen. Then after that, we'll transfer it into a liquid nitrogen container immediately, like that, which is at negative 196 degrees now. Yeah. Yeah. So that is the entire process. Of course, after that, we'll check 1 or 2 doses whether everything went okay. And if everything went okay, then that semen is now going to be sold to our customers.
In this episode, we recognize the critical role they play in empowering livestock breeders to harness the power of genetics and pave the way for future genetic excellence. Join us next time in the final segment as we unveil the remarkable impact of high-quality semen on livestock performance and productivity.